Hey guys, welcome to Crown Smart. In this video, we are going to differentiate logarithm of x with base a. Okay, let's start. Now we have that our f prime of x by definition is the limit as change in x approaches 0. We have f of x plus change in x minus we have f of x all over what? Change in x. Now we know that our f of x is already this. Is already log x with base a. So our f of x plus change in x is simply the logarithm of what? X plus change in x with base what? A. Now we go back to our definition, which is f prime of x is equal to the limit as change in x approaches 0. Now what is our f of x plus change in x? We have this as our log x plus change in x with base a minus what is our f of x? The logarithm of what? X with base a all over what? Change in x. All over this. Now this is equal to the limit as change in x approaches 0. Now remember your logarithm rule where you have log m minus log n. This is the same thing as saying log m all over n. Remember this has a base a, the same base, so we put the same base here. It only works with the same base. So we have this as log x plus change in x all over what? X. Now with the same base a all over what? Change in x. Now this is equal to the limit as change in x approaches 0. We have this as the logarithm of this will be, if you simplify this, you have this as 1 plus change in x all over x with base a all over what? Change in x. How did I get this? X plus change in x over x is simply x over x plus change in x over what? X. This cancel this. We have 1 plus change in x over x. Okay. So now this is the same thing as saying the limit as change in x approaches 0. We have this as 1 over what? Change in x multiplying the logarithm of 1 plus change in x over x, okay, with respect to the base a. Okay, now remember one of your law of logarithm that says log b with base a is the same thing as saying ln b all over ln a. Okay, you take the ln of b all over the ln of a. This has a proof. Okay, so we are going to apply it here. Okay, so this is going to be equal to the limit as change in x approaches 0. This will now be 1 over change in x, okay, times this will now be the ln of what? The ln of 1 plus change in x over x all over the ln of a. Remember when I said ln is actually logarithm with respect to the base e. So this is like saying logarithm, let's say logarithm of a or with base e is the same thing as ln a. Okay, this is actually what ln means. Okay, now we're not done. So if we simplify this, we are going to have this as this is equal to the limit as change in x approaches 0. We have this as 1 over change in x times 1 over ln a times the ln of 1 plus change in x over what? X. Okay, now 1 over ln a is a constant, okay, so we can bring it out. So this is going to be 1 over what? Ln a is a constant. So we have this as the limit as change in x approaches 0. Limit as change in x approaches 0. We have 1 over what? Change in x times the ln of what? 1 plus change in x over x. Okay, now observe, as change in x approaches 0. Oh, sorry, before I do this, the first thing I'm supposed to do is let change in x over x equal to t. Now this implies that change in x is equal to what? Xt. So we let change in x over x equal to t. Now observe, as change in x approaches 0, t also approaches what? 0. Now I'm going to give a just simple example to illustrate this expression. Let's say, for instance, let's make a table. Let's say x is equal to 5, and we have change in x, and we have t. Now let's say this is 5, 5, 5, 5, 5. Okay, we have 4, 3, 2, 1, 0.5, 0.1. okay, let's say 5. Now our t is equal to what? Change in x over x. Now what do we have here? Now t will be 4 divided by 5, which will give us what? 0.8. 3 divided by 5 will give us 0.6. 2 divided by 5 will give us 0.4. 1 divided by 5 will give us 0.2, and so on, 0.1, and so on, 0.02. Now observe, what do you observe? As change in x is approaching 0, as it's decreasing to 0, t is also approaching 0. It's also decreasing to what? To 0. This is just a simple illustration of as change in x approaches 0, t also approaches 0. So what we now do is this will now be f prime of x is simply 1 over ln a, okay, and therefore we write the limit as t approaches 0 because we want to change everything now. So this will now be 1 over what? Xt. Remember when we say our change of x is what? Xt. Okay, multiplied by the ln of what? 1 plus t. Change of x over t becomes what? Change of x over x becomes what? T. Now, so we also recall that if we have 1 over ab, this is something as saying 1 over a times 1 over b. Okay, so we'll do that here. Now the reason I want to do this is because I want to remove 1 over x out, because I'm finding the limit of this function as t approaches 0. So I want it to only affect t, so I'll remove 1 over x out. So this will be 1 over x, this dot means multiplication, dot 1 over ln a. Then I'll now write the limit as t approaches 0. I will now be left with what? 1 over t multiplied by ln 1 plus t. Okay, we're not done yet. So simplifying this, we are going to have this is equal to 1 over x ln a. Now we now have this as the limit as t approaches 0. We have 1 over t times the ln of what? 1 plus t. Now recall if we have recall our logarithm rule that 1 over t log m with respect to base a is equal to the logarithm of m with base at, a raised to the power of t. So we are going to apply that rule here. We're going to apply that rule here. So we are going to have this is equal to 1 over x ln a. We are going to have the limit as t approaches 0. This will now be the ln of what? 1 plus t. Then we are going to have this as remember, whenever I wrote ln is the same thing as saying logarithm with base e. So instead of writing ln here, I'll write the logarithm with base e. The reason is that I want to put this t here. So that will now put t. That 1 over t will now change to t here. Remember our rule now. 1 over t log m with base a is equal to logarithm of m. Then our base now becomes a raised to the power of t. Now, so since our lane is the logarithm with base e, I'll just change it to logarithm with base e, so that I'll be able to put the 1 over t here. I'll put the t here. Now, to remove this limit, this is equal to 1 over x ln a. As t approaches 0, what happens? Anyway we see t, we put 0. So this becomes the logarithm of 1 plus 0. Now e raised to the power of what? 0. Now anything raised to the power of 0 from our law of indices is what? 1. So this is 1 over x ln a, the logarithm of what? 1 base what? 1, because e raised to the power of 0 is equal to what? 1. So recall our logarithm recall that log a with the same base a is equal to what? 1. So therefore this is equal to what? 1. So this is the same thing as saying 1 over what? X ln a times what? 1, which is equal to what? 1 over what? X ln a. So therefore our f prime of x is equal to what? 1 over what? X ln a. In general, whenever we are differentiating a logarithmic function in general, okay, we are going to have 1 over x ln a. Now, let's say a special case where we have our f of x is equal to what? Our f of x is equal to what? Log x with base a. Let's say this our a is e. Let's change it to e. Okay, now our f prime of x here will simply be 1 over x ln e. Remember the a here, I change it to what? E from here now. So what is ln e? From our definition, ln e is equal to what? 1. So this is already what? 1 over what? X. So if we are differentiating ln x or logarithm of x with base e, ln x or logarithm of x with base e, we are going to have what? 1 over x. Okay, now but the general form of it is 1 over x ln a, when a is what? Arbitrary. Please, I hope you enjoyed this video, and I really appreciate if you subscribe. Please do not forget to subscribe, share to your friends, and like this video. Thank you very much. God bless you.